The aiCarPaint shader can simulate a base paint layer, metallic flakes, pearlescent effects, and a transparent clear coat. It can be used not only for cars, and many other glossy products. First, select the object, create an aiCarPaint material, and assign it. For clarity, I'll temporarily set the coat weight to 0 during this demonstration. Let's start with the base layer. This is the main paint layer underneath the entire car finish. Color determines the base paint color. You can choose any color you like. Weight controls the strength of the base layer. Lower values reduce its influence, while higher values make the base color more prominent. Roughness controls the surface smoothness. Lower values create a smoother finish, while higher values produce softer, more diffuse reflections. Next is the specular layer, which controls the reflections on the paint surface. Weight controls the reflection intensity. Lower values reduce reflections, while higher values create stronger highlights. Color controls the reflection color. Flip-flop is one of aiCarPaint's unique features. It changes the reflection color depending on the viewing angle. When using a solid color, the difference between specular color and flip-flop color is subtle. Let's connect a ramp texture to better demonstrate the difference. Connecting a ramp to color applies the colors based on the object's UV coordinates. However, connecting it to flip-flop changes the color based on the viewing angle. Similar to the facing ratio node we covered previously. This is one of the key features that makes aiCarPaint different from AI standard surface. Light-facing color controls the reflection color seen when looking directly at the surface. As falloff approaches 0, the light-facing color covers more of the surface. Increasing the value gives more influence to the flip-flop color. Roughness controls the sharpness of reflections. Lower values produce crisp highlights, while higher values create softer reflections. IOR represents the index of refraction and affects Fresnel reflections. Higher values increase reflections around the edges. Next is Flakes, one of the core features of aiCarPaint. Flakes simulate the metallic and pearlescent particles embedded in automotive paint, giving it depth and sparkle. Let's increase the scale value slightly. Scale controls the size of the flakes. Density controls the number of flakes. Higher values create a denser distribution, while lower values spread them farther apart. Color, flip-flop, and light-facing color work the same way as before. But they affect only the flakes layer instead of the base layer. By assigning different colors to flip-flop color and light-facing color, then adjusting falloff, you can create angle-dependent pearlescent color shifts. Color determines the flake color. Besides silver and gold, you can create flakes in virtually any color. Finally, we have the coat layer. This represents the transparent clear coat covering the paint. Real cars also use a clear coat to add depth and enhance gloss. Weight controls the strength of the clear coat. Color controls the coat tint, although white is used in most cases. Roughness controls the smoothness of the clear coat. Lower values create mirror-like reflections, while higher values produce softer, matte-like reflections. IOR controls the index of refraction of the clear coat. Higher values increase edge reflections. You can connect a separate normal map that affects only the clear coat. I'll use a scratched normal map as an example. Make sure the normal map's color space is set to raw. I'll temporarily lower the flakes density to make the scratches easier to see. This allows you to add fine scratches to the clear coat while leaving the base paint untouched. To remove the normal map, simply use break connection. Finally, I'll restore the flakes density to its original value. That concludes our overview of the Arnold aiCarPaint shader. Thank you for watching. If you found this helpful, please subscribe and hit the bell for more Maya tutorials. Thanks.